Hi, I'm Nick Karapanos, a student in Mr. H's Man Environment class at Harper College. Today, I'm going to be talking about predator-prey cycles in a shared ecosystem between populations. A year ago, during the summer, I was walking Max here around the pond when I noticed vegetation that hadn't grown here in previous years. I also noticed a little sign that read, "These plants were planted here in order to attract dragonflies." We won't really see those plants here now that it's winter and the plants have died off. But what I saw at the time was meadow sage, white yarlow, and swamp milkweed. But why attract dragonflies? While I find them very charming for their visual appeal, I wasn't very fond of bugs, especially mosquitoes that were already at the park. So why attract more bugs? Didn't really make sense. With a little research and some new knowledge from my Bio 103 class, it became apparent that the park district was trying to reduce the mosquitoes population by promoting a better environment for the dragonflies and increasing their populations. And that's where our topic of predator-prey cycles comes into play. The concept is really quite simple. It's based on the feeding relationship between two species, where one species is considered the prey, or the organism that is hunted and killed by another for food, and the other is the predator, or the organism that hunts and feeds on the prey. If the prey species rapidly multiplies, there's an abundance of prey for the predators to feed on, which increases the number of predators. This continues until the predators eat so much of their prey that the prey population dwindles. This in turn decreases the predator population due to starvation, because there's less prey for them to feed on. This decrease in predator population leads to the prey population rapidly increasing again, where we enter this cycle once more. The graph displayed here shows this information. On the left, we have the relevant predator and prey population sizes, and on the bottom we have time. Here we can see the cycle visually. The top curve is the prey population and the bottom is the predator population. We start with a high population of prey in this environment, in our case the mosquito population, and a low population of predators, or dragonflies. As we can see, as the prey population curve goes up as they reproduce, this causes the predator population curve to go up also, because their numbers are increasing due to the surplus of food, or in our case the mosquitoes. But when the predators feed too much on the prey, we see that the prey population curve plummets. With less food around, the predator population decreases as some members die off due to starvation. The park district aimed to increase those numbers through planting vegetation that provided hiding and resting places for the nymphs. They also are used as incubation chambers because some species insert their eggs into the soft stems. Rocks are also a good addition to the pond for the dragonfly. Since they are cold-blooded, they like to bask on these rocks in the hot sun when they warm up. These rocks also provide something for the nymphs to cling, climb, and hold on to as they molt into their adult forms. Tall plants like this one that stick out of the water provide places for adult dragonflies to perch and scan for food or mates. They also allow for a place for nymphs to climb up and undergo the transformation process from nymph to adult. Since the nymphs emerge with soft bodies, it takes several days before the wings harden completely and they can fly. These plants provide excellent coverage in the meantime from things like birds or ducks higher in the food chain that might feed on the nymphs. Conditions cause our dragonfly populations to increase, and with that, our surplus of prey is rapidly diminished. Dragonflies are natural predators for mosquitoes. In fact, they eat them through all stages of their life. An individual dragonfly can eat anywhere from 30 to hundreds of mosquitoes a day. This feeding frenzy won't last long though. The dragonflies will eventually find it harder and harder to find mosquitoes as their numbers increase, and the mosquito population decreases, eventually leveling off the dragonfly population. There are also many other factors that affect population size of these species, such as competition between themselves and other predators. Density-dependent factors like increased risk of disease or parasites. Density-independent factors such as catastrophes like tornadoes, hurricanes, or wildfires. Temperatures, rainfall, sunlight also play a role in the population size of a species. There will be many increases and decreases in the population over time, but the ecosystem will always have a maximum sustainable population size that is known as the carrying capacity. When a population overshoots their carrying capacity of their environment, resources become limited. Death rates rise, and there's even a chance the population might crash. Introducing a new species or more of a species in an environment will always have a dominant effect in the ecosystem that we don't always realize. That doesn't mean for better or for worse, but predators are critical for the health of the ecosystem. They ensure that a greater variety of species survive and thrive by keeping prey populations in check. Biodiversity boosts ecosystem productivity, where each species, no matter how small, all have an important role to play. Whether it be supplying oxygen, clean air and water, pollination of plants, pest control, wastewater treatment, and many other ecosystem services that we don't always realize but enjoy. For me, it's the summers that I have a few less mosquito bites on my legs thanks to a little help from our friend the dragonfly. This is Nick Karapanos signing off.